All right, so going to try and go over a good number of these. So on this paper first, so this was the one I handed out today. Starting with 61. Consider the diagram and the given statements for a proof. So we have this. Now there was a typo on here. There was a typo on 61, which I pointed out in 8th period, but that was the only period that had noticed it. That on D is supposed to be a D, because that's the only one that actually makes sense as a final thing. Because if these are your statements, and you're starting with this, and this is what their last statement is, that should be your given, right? This should be given, and this should be what you're trying to prove. So, if you look at D, that's the only one that matches the first and last statement. So D should be the correct final answer. But there was a typo because it said AB instead of AD. So, yeah. But it was a typo. D is the correct answer because, again, given should usually come first and your proof statement should come last. And based off that diagram, that's the only one that makes sense. So, there was a typo. All right. Number 62. You had this diagram and you had to fill in a proof for it. So, there's no easy way for me to do this one, since it's like kind of catty corner there. But they had the proof up here, so I'm going to show the proof while I go through it, and then you just have to look at your diagram. But they gave you the first part. That was what was given to you, right? So BD bisects CBE. Now, you also had a second given. Which one of these was also given to you on the picture? Number 4. So that could also be given. Now, other things. All right, there are 3 other blanks. So I don't even really have to look at the picture because I can just go off of what this says. So we have angle 2 is congruent to angle 3. Well, that came after the statement of having a bisector. So what do you think it's going to be? Definition of angle bisector. Can you please stop with the bottle? All right. So then, yeah.
Why isn't that definition of congruent angles?
So the next one is definition of congruent angles. This one's not because we have to have somewhere to start, right? Definition of congruent angles is going to tell us that we either have congruent angles, therefore the measures are congruent, or we could have switched these two around, and then you could still use definition of congruent angles. So it's either going to tell you that 2 angles are congruent, therefore their measures are equal, or we have 2 angles whose measures are equal, therefore they're congruent. But it's going to be when we switch between equals and congruent. That's when we use that one. All right. This one, we know they're congruent because of the bisector. All right. Now, let's see. There's a couple other blanks. On this one, we had measure of angle 1 plus measure of angle 3 equals 180. Well, how that changed from the previous statement? They replaced angle 2. Well, if we're replacing angle 2, that's substitution. All right? So that's substitution property. Now, the last statement should be what we're trying to prove. So what were we trying to prove? Angle 1 is supplementary to angle 3. So, well, if we said that these 2 angles add up to 180, and now we're saying they're supplementary, that's our definition of supplementary angles. Yep. On 64. So it says complete the proof. Now, the proof is actually on the next page, so let me put this next to it. So on this one, we have angle RBT is equal to 2 times measure of angle 1. So that's what's given. What we're trying to prove is that BS, ray BS, bisects angle RBT. That should be the last statement. Now, yeah, so on your paper, it's like this, so it's kind of, yeah. So I have a slightly bigger one so that I can write on it. But it's on the same page for you guys. All right. So now, we have the given, but this does not follow what's given. This is based off of the figure. Angle addition postulate. We're adding these two angles to get the entire angle. So, the entire angle is RVT. So I can say measure of angle RVT equals measure angle 1 and 2 added together. Now, you could also list those out with the 3 letters, but it would take more room if you're going to write it out with the 3 letters. So you can just use the numbers that were in between them. And if you look at the one after it, you'll see it had measure angle 1 plus measure angle 2 on this side of the equation. So really, you should write it on the same side like that one had it. If you flipped it around, it's okay, but technically you'd have another step in between. All right, so now from this to this, the only thing that's changing is RVT was replaced with what they gave us originally. So that's substitution. You could also, so really there's 2 possibilities here. Substitution, or you could say transitive, because that entire equation was equal to RVT, this entire equation was equal to RVT. So either substitution or transitive would work. Those would both be correct. All right, then on step 5 down here, we were missing a step. We went from being equal to being congruent. So this is definition of congruency, or definition of congruent angles. And then finally, since those two are congruent, that means that this must be an angle bisector, because that's our definition of angle bisector. All right. On 65. Critique the reasoning of others. A student says her statement below can be justified by the definition of complementary angles. If angle A and angle B are both complementary to angle T, then A is congruent to B. All right. That can be justified. What's the justification for that? It's kind of like transitive, but there was an actual theorem for this that it was proved using transitive property. This was congruent complements theorem. We had 2 theorems in the Springboard book that we had done and proved: congruent complements theorem and congruent supplements theorem. They were both in the same section. I think it was in 6. I don't think we asked that one specifically on the test, but it's something that you could use. But yeah, that was back in, I can't remember if it was 6.1 or 6.2. I think it was 6.2. But it was in there. We did that proof. We did the proof for it. If we do the proof, you can use it. But again, there's 2 separate proofs. I think one was in the practice and one was in the the examples. But we proved those 2 theorems. And I talked about, when I went over this, I talked about we did these also way back in like the very first section of the book. We did them back then as well. There's 2 questions in the Springboard that asked us to explain in words why, if these 2 things were complementary to the same angle, that they would be complementary to each other. And we explained it in words. And then in 6.2, we went back and actually did a proof for it. All right. Anyway, 66. Use the protractor shown. So on here, find BAC. Here's BAC. This 0 on the inside, I'm going to use. So going up on the inside, that's 55 degrees. Then BAD. BAD. Well, that whole thing all the way over there, that looks like it says 100. So that would be 100. CAD. Fast way to find CAD, since it's this angle here, well, it would be this big angle minus this little angle. So 100 minus the 55 would give us 45 degrees. And that'd be it. So then on D, suppose A P bisects DAC. So it's bisecting this. Well, that's 45 degrees, we just found. Then we have to go 22.5 degrees from either one of these. Since everything's coming from this side, I'd use the inside angles here. So do the 100 minus 22.5, and you'd be at 77.5. Again, that's the mark you'd be at, 77.5 degrees. That'd be on the inside, or you could do the appropriate outside measure as well. Would also work. All right. I think I did that one before, so maybe another tutoring session. Well, I could have done the 100 minus 22.5, or I could have done this 55 and added 22.5 and get the same thing. But it's halfway in between here, so I had to do half of 45. Half of 45, 45 divided by 2 equals 22.5. We got to either subtract it from 100 or add it to 55. Either way, you get 77.5. Yeah. On 69. Suppose that angle 2 and angle 3, angle 1 and angle 2 are same side interior angles formed by two parallel lines cut by a transversal. Then measure angle 1 equals that. So you got two different things. What's the value of x? First, since it's saying same side interior angles, you know what about those two pieces? They're equal to 180. They have to be supplementary. So we're going to take those two measurements and set them equal to 180. So 7x minus 4, not plus, minus 4, plus 20x minus 5 equals 180. 27x, that gives us 9. Ignore the bell. Add the 9, and you get 189. Divide that by 27. I don't know what that is off the top of my head. What'd you get? I got 7 too. So, x equals 7. For angle 1, plug it back in. So, 7 times 7 minus 4. 7 times 7 is 49. 49 minus 4 is 45. Again, that'd be in degrees because now we're talking about an angle measure. Measure of angle 2. Plug it into the second one. 20 times 7 minus 5. 20 times 7 is 140. 140 minus 5 is 135. All right. On 70, complete the proof. Oh, there's a D. Sorry, I missed the D. Explain how you found your answers. So, first off, same side interior angle theorem. Same side interior angle theorem says they are supplementary. Depends how long-winded you want to get, but you can say that they are supplementary, therefore you set them equal to 180. Once you solved for the variable, you plugged it into each of the equations. I'm going to stop at that. All right, number 70. We have two parallel lines cut by transversal. They told us these two lines are parallel. All right, so we know that they're parallel. How? It was given to us. Then we can say angle 3 is congruent to angle 7. Well, 3 and 7 are corresponding, and 1 and 5 are also corresponding. So, corresponding angle partial. Then, since we know that they are congruent, they must be equal. That is the definition of congruent angles. And that's what they had there. And then we know that 3 and 5 add up to 180. So 3 and 5, those are same side interior angles. Yeah, we can go ahead and use that here. So same side interior angle theorem. And then finally, substitution, we're going to replace the values of 3 and 5 with 1 and 7. And that'd be substitution property, and that's what they want us to prove. So replace both those values with things we said were equal to them earlier. Okay, and then 73, and then I'll do the other couple from Oswald's. You want this one? Alright, so on 73, use the diagram below. Determine which pair of lines it must be parallel for each statement to be true. So, in order for angle 2 and 4 to be congruent, M and N would have to be parallel. For 2 is supplementary to 13, 2 and 13. In order for those two to be supplementary, what? Determine which pair of lines, if any, must be parallel. So, in order for this statement to be true, you'd have to have more than just the lines being parallel. You'd have to be P and Q parallel, but then you'd also need M to be perpendicular to one of those. Doesn't matter which one you say. But you'd need more information. If you want to say that there's not enough information there, that's fine. Or you could say this, and then it'd be true. Because normally, those two wouldn't be supplementary, they'd be congruent. The only way to have those be congruent is if not only those lines are parallel, but also that be perpendicular, so that both of them are right angles. If both of them are right angles, that's the only way you can have them be supplementary. So, a little bit extra there. On the next one, 2 and 13. So there's 2, there's 13. How are they congruent? So now that one makes more sense. Again, P and Q would have to be parallel. 5 and 10 congruent. There's 5, there's 10. They're alternate interior angles. So again, P and Q would have to be parallel. 5 and 12, there's 5, there's 12. In order for them to be congruent, you need both sets of lines to be parallel. So you need both P parallel to Q and M parallel to N for that to be congruent. And then 2 and 4, 2 and 4, those are corresponding angles, so M and N would have to be parallel. Alright. So that's those again. We good there? That was the last one you guys asked me for, right? So let me go over to... Oh no, there was another one there. 80. 80. I missed 80. Okay. We're almost there. In this diagram, so it gives you a bunch of different angle measures there. Or sorry, not angle measures, segment lengths. So it tells you this one is that. That's that. That's that. Gives us an angle. X is 2. Which segment is the perpendicular bisector of the other? Alright. So, first things first, they gave us the X was 2. So let's plug it into the angle to make sure that this is a right angle. Because ATD would have to be 90 degrees in order for this to even work. So 41 times 2 plus 8. 41 times 2 is 82 plus 8 is 90. So that is a right angle. So it's definitely a right angle. Now, we also need to see which ones are congruent because it wants to know which one's a perpendicular bisector of the other. So plug 2 into each of these equations. So for AT, if I plug 2 into that, 2 times 2 is 4. 4 plus 3 is 7. For ET, plug 2 into that. 3 times 2 is 6. Minus 1 is 5. BT, plug 2 in. 2 plus 5 is 7. Plug 2 in for dt. 4 times 2 is 8, plus 1 is 9. So AT and BT are the two that are congruent. So which one's the perpendicular bisector? CD. CD is the perpendicular bisector to AB. CD is perpendicular bisector of AB. Alright. Okay, let's go to that other sheet Miss Oswalt had given out, and I'll post a blank version of this for my class. So on number 4, complete the 2-column proof. Now, man, this one was completely blank. So the given definitely should go first.
Can I see the paper that you just
This paper?
Yeah, I was thinking.
So now, you could, again, list both of your givens first if you wanted to. So I could do this entire thing and this entire thing in the first line, or I could split them apart. Either way would work. Again, I'm not sure how many spaces she has on here, so I don't know if it's going to work out perfect. Yeah, did she list these out as 2 separate statements?
Yeah.
She did? Okay. So I'll do that as well. So S is, man, I don't like the way that's written. S is perpendicular to P. You can just use a perpendicular symbol. That's given. Now, you could go ahead and list your other given if you want to right now, or if we know other information because of this, we could go ahead and list some of that out as well. They want us to prove that P is parallel to Q. So P is parallel to Q. Let's see, what else do they tell us? 1 and 2 are complementary. Alright. So, let's see. What do we have to work with? And let's see. S perpendicular to P. Alright, so we could go with let's go ahead and list this one out. Angle 1 and angle 2 are complementary. That is given. Now, since those two are complementary, we could say that, I don't know how specific she got here, so measure angle 1 plus measure angle 2 equals 90, right? Did she do that? No?
She put the next thing after the first given, she put measure of angle JHP equals 90, and then the other given. Wait a second.
Yeah, you can do this a couple different ways. There's several different ways. Definition of complementary. Yeah, when she gave this to me, she said that there's several different ways you could do this one. So my way might not match hers exactly.
Yeah.
But we got, all right, those two equal 90. If those two are equal to 90, then we know that this is a right angle, right? So angle, man, really you should write this out as a separate step though. Measure of man, I feel like this is way too short. Because like there's a lot of things that you should be saying here. Did she skip things? Hold on, let me see that.
She always puts the second given as in the third section. That's what she does. She told us to do that. Yeah.
She told us to see what you can do, and if you can't do anything else or write anything else, then you put the other given.
Oh, okay. So she did that instead. Okay. So when I saw this, I was not thinking the way she thought here. What I saw as soon as she gave me this, so let me briefly describe what I saw, because there are lots of different ways you can do this. her explanation, she ends up using converse of same side angles theorem,
I didn't understand
which
that.
that's fine. You can do that. But when I saw I had a right angle there, the first thing that popped into my mind was the perpendicular line postulate, because perpendicular line postulate says, or no, I'm getting that one mixed up too. There's another postulate or theorem. That. There you go. I'm trying to remember which theorem that is now, because there's a theorem in 8.2, I believe it is, that says if you have a line perpendicular to a line that's parallel to it, then it's perpendicular to both lines. I think it's on that one. Give me 1 second just to find it in here. Oh no, that's the wrong one. It's 7.2, I think. Oh, there it is. So, this one. The perpendicular transversal theorem states that if a transversal is perpendicular to two parallel lines, then it's perpendicular to the other line. That's what I would have thought that it was going for, so that's where I was going with it. I might have to do an extra step in order to get that done. But if I can show that both of these lines are perpendicular to this one, then I could use perpendicular transversal theorem to state that the lines are going to be parallel. Does that make sense? So, again, more than one way to do this, but maybe I should go her way so that it makes sense. Because then we can say that measure of angle P, no, is there, there's not even a number on that. You'd have to give that some number. So I'm going to go ahead and call that angle 3 for now. Measure angle 3 equals 90. And I can say that because they told us that they were perpendicular at the beginning. Therefore, that's definition of perpendicular. This one, in order to actually say that we're talking about this angle here, we really need to do this in 2 steps. So there's not actually enough room here for even the way she did it. I don't know how she left out a step, but
She left out a step?
I think so, because you would still have to say that these two add up to be this entire angle, right? And we can't leave that out. So you'd have to say measure of angle 1 plus measure of angle 2 equals this, which we can call HJK, because that would be our angle addition postulate. And then I'm going to skip that for just a second, because now we can replace this piece that we had up here, because this whole thing was equal to 90, and either say substitution or transitive property. So either transitive or substitution would both work here. And then finally, now that we have both of them are 90, we can say that we have these two lines are parallel because of same side interior angle theorem. So I'm not sure which step she skipped, but there has to be one more step there, I think. Same side
What is a converse
interior angle.
side?
Yeah.
That's what
Oh,
confused me the last
sorry.
part.
Thank you. This last one should be converse, because we're saying that the angles are the same, therefore the lines have to be parallel. Because if you were to say that the lines are parallel, therefore they're going to be the same measure, that would be the regular theorem, right? Given that they're parallel, you have all those properties. But if you're trying to say that the lines are parallel, then you have to use the converse of them, because you're switching the if and the then statements.
Will that be on like the test?
It,
Converse, inverse, or anything like that?
it could be, because it was kind of heavy in one section. I'm not going to say it's definitely there. Truthfully, I think we left it off, but I don't remember.
I hope so.
Yeah.
Because I was confused.
Yeah. Let's. Yeah. What didn't she not have? Perpendicular given. Chance of substitution. J. Yeah, I don't know how she went straight to that. JPH. Wait, no? That doesn't make sense, does it? J.
She's been making a lot of math mistakes lately, so.
She can replace 90 with JPH.
Alright, I'm out.
Alright, have a good one.
Yeah.
But that's not saying that those two are congruent. Because really, technically, I should have went even further. Because I even left off steps. Because on here, you really should have got it back to being congruent before you said
So
this.
needless to say, there won't be anything right now for the test tomorrow. There will not be
No,
like blank.
no, it's not going to be blank.
This is
Because
gonna be fill in the
technically, in order to even do this, I tried to wrap it up in these two steps. But technically,
You have
in
to
order to
fill out
use
one.
this, we would have had to say that these are congruent first, those two angles. The best I did was say that they were equal to 90. So technically, you'd have to say that this angle that I called angle 3 up here is equal to this one because they both equal 90. So you could use substitution property. And then once you said that they're equal, then you can say that they're congruent. So that would be another line even. And then once you said that they're congruent, then that's really converse of same side interior angle theorem. So I feel like this really has to be like 3 or 4 more steps than what's on here to really be accurate.
Lord.
I think I could have done it shorter using the other this other theorem, because all we would have had to do is prove that they're perpendicular, and then we could have went with that. But I don't know. That one's kind of messy. Did you? Was 6 one of the ones you wanted to go over?
No.
No.
That one.
Okay. All right. I'm gonna stop this. Do I stop this? Yeah.